Hey everybody. Today we're working on 4-6 polynomial and rational functions. So just really generally speaking, like in your description, this section involves graphing and inequalities. If you're asked to graph or find out where y is greater than 0, then it's above the x-axis. And if it's for where y is less than 0, then it's below the x-axis. So just real quick as a side note, if you were to graph 3x squared plus 4x minus 4, what you're going to do is find out your x-intercepts. Like in this case, I have approximately 2/3. We ignore this 0.86, or this part at the very end that's 8.6. And so we could say it's below here, which means less than 0, and it's above here. And you're going to see problems like that where it actually breaks it up. So you will need to pay attention to whether it's closed or open or half of each. You also are going to see something about solution set notation, where you have inequalities, and also interval notation with your unions and with your infinities and negative infinities. In general, your steps for solving them algebraically are write the equation, so f is on the left side and 0 is on the right. Be sure that the left side is written as a single quotient, which means a single fraction, and find your domain. So on that, we usually set your denominator equal to 0. Step 2, determine the real numbers at which the function equals 0, and if it's rational, where it's undefined. Step 3 is use the numbers to separate them into intervals. That's basically it. Okay, so that's your 3 steps. Now, more specifically, I'm having to do my notes a little bit different this time because it's so graphical. But basically, why we're studying this is in this section we'll solve polynomial inequalities both algebraically and graphically, and solve rational inequalities both algebraically and graphically. Now, inequalities when you have degree 3 or higher is in this section, but quadratic ones were in Algebra 2. Okay, so a lot of this is like straight from the book. As far as your interval notation, they want a smaller than b. If it's a closed interval, it has brackets, and so that means a less than or equal to x less than or equal to b. And the open interval has parentheses, and so that's a less than x less than b. If it's a half, you could say a less than x less than or equal to b, which looks like parentheses a comma b bracket, so those go together, or these that go together. Since it's a less than or equal to x, it's bracket a, and then the b part was with the parentheses over here. Okay, so you got to pay attention to that part. We graph them and determine the intervals for which the x meets the criteria. Okay, so we want to graph this particular one and solve it, determine where it's greater than 0, and this represents x being, or f of x being positive. So when we just graph something, or if we look at the graph, it's above. So in this case, from -3 to 0, actually -3 all the way to 1. So -3 to 1, and also you could say from 1 to infinity. So they did break it up into 2 separate parts because it's decreasing here and increasing here. I suppose that's the reason why. Okay, so there's that one. On this one, it says write the inequality, so you have your polynomial on the left and the 0 on the right. So if you have something like this, x to the 4th divided by x, you're going to want to subtract, not divide. If you subtract, you'd lose a solution with x equals 0. So our first step is just move it over. The second step is to determine the real zeros, which are the x-intercepts. So we factor out the x, and then you're left with the cubic, x cubed minus 1. And when you have the difference of two cubes, it would end up looking like this. You'd have x minus 1 here, and then x squared, and then you got to change your sign from negative to positive, and then you have your x plus 1. So that's how that's related. You might want to do similar question to see what happens when it's 2 or 4, just to see like what different numbers it goes to. But in general, it's like if you have x minus 1 here, then you'll have x plus over here on this side. But sometimes you have a coefficient. Okay, so now based on that, this part is x equals 0, this part is x equal 1. Now this part is what we call the irreducible quadratic, so that has no real zeros. Even if you were to graph this one, you wouldn't be able to get your solutions to that. Now, when we're solving this inequality, we're going to want to divide it into using your numbers. 0 was there, so that's why they split it with 0 there. And 1 was the other one. So they go to the left of 0, in between, and to the right of 1. Okay, so then they have a table, and they want you to test where it's positive and negative. And they choose different numbers, like if you're going from negative infinity to 0, you could have chosen -1, -10, -100, whatever. But in this case, we're choosing -1. And so when we plug that into the x, we get a 2 in this case, and so it's positive. Then you want to choose a number between 0 and 1, so you choose a half, a third, a fourth, whatever, or 2/3. And when we do that, we get a number that's negative. And then you can choose any number greater than 1, so 2, 10, 100, whatever. And in this case, it's positive. So it does go positive, negative, positive. Since we want f of x positive, then we basically use this part and this part. So we say negative infinity, 0, union, 1, infinity. And that's the interval notation. The solution set was this, with x less than 0 or x greater than 1. So that's basically how that's going to work. On this one, we have greater than or equal to 0, and we have to graph it this way first. And when we do that, we get this graph. So this is -2 and 2, where you have your asymptotes. We have x squared minus 4 equals 0, x squared equals 4, so x is plus or minus 2. So here's your -2 and 2. So those are your vertical asymptotes. Now looking at the graph, we want to see where it's above, and that's when x is greater than 2. And it's also greater, where it's above the x-axis. It's also above from here to here, which is from -2 to 1. So we could say -2 less than x less than or equal to 1, Um, and then this end was x greater than 2. So then you just put those together. Our interval would be from -2 to 1 with a bracket at the 1, union 2 to infinity. The reason why this 2 doesn't have a bracket is because that's where the vertical asymptote was. And same thing on this side. So that's why with the parentheses we have to do the vertical asymptote. In the same way, that's why we use less than instead of less than or equal to. So pay really close attention to that. I know that part can get confusing and frustrating sometimes. So then for our next part, it says to solve it, we follow the same approach for the polynomial. However, we have to also identify zeros in the denominator because the sign could change. So first we have 4x plus 5 over x plus 2 minus 3 greater than or equal to 0. It already has 0 on the right, so that's actually what we want. The tough part about this is you want to get a common denominator here, and so we have to multiply by x plus 2 over x plus 2. And so then you distribute and write it as a single quotient. So in other words, -3 times x is -3x, and -3 times 2 is -6. And then you got to simplify it, and 4x minus 3x is x, and combine your other like terms also. 5 minus 6 is 1, negative in this case. So then you have that, and then from there we interpret it. It's undefined at x equal -2, and then we use our -2 and our +1 sections of it, and then we do our chart for where it's positive, negative, and positive. I kind of do like the chart, but if you're just graphing, I guess this one didn't graph it for you. If you just type this one in the calculator, you can just say it's above, it's below, and it's above. And that would do it. So you want to the left and to the right where it's above. And so in interval notation, that's -infinity to -2 with the parentheses, because that's where the asymptote is, and then including 1 going to the right. So then this is a repeat of what I read earlier about your steps. I won't go through it again, but basically you've got to determine your real numbers and separate it. And then step 4, select a number and then decide where it is. Okay, so now let's actually get to the problems. Okay, that's about 12 minutes in. Okay, so solve the inequality, express your answer, and they are giving you both versions of it, and then they want you to graph it. So here we have 2 minus 4x less than or equal to -6. So if we follow our process, then we'd say 2 minus 4x plus 6 less than or equal to 0. So basically add 6 to both sides, and 2 plus 6 is 8, so 8 minus 4x less than or equal to 0. Now, right there you could look for your greatest common factor. In other words, you can factor out a 4, because 4 times 2 is 8. And so this end would just end up with 4 times 2 minus x less than or equal to 0. So then at this step we have 2 minus x less than or equal to 0. Add x to both sides, so it's 2 less than or equal to x. And then that seems simpler, than like multiplying or dividing by a negative. So that's why I did that. And then we usually rewrite it if it's a one-sided limit with the variable on the left. So that's just x greater than or equal to 2. And so that's what we wanted, x greater than or equal to 2. And then the other way to put it was bracket to infinity. So to infinity and beyond. Okay. So there's your number line graph that we want. The main difference between these two is it includes the number. This one does not. Does not include 2, like an asymptote. But in this case, you know, we're just graphing, so we've got that. Now this is just like a number line graph, but I suppose if you want to, we can graph this step. We know we could put 8 minus 4x. Now, by the way, make sure you hit this minus sign instead of the other one, because we want 8 minus 4x, enter, which is there. And if you just graph that step and we want it less than or equal to, that just means below. And then you can figure out, okay, from 2 on, it's below. I mean, that's basically it. Now, going back to what I was saying, if you use this other negative sign that's below the 3, and if you say 8 negative 4x and press enter, that's a different graph. It's like steeper or something weird. And when I go into it, it actually says 8 times negative 4 times x, which is not what we want at all. So that's why we need to be careful about using the correct negative sign. So delete these parts and put the regular minus, and then it's right. And like I did on my very first example, if you wanted to, you can go to 6,1 and trap it, and there's your 2, 0. So we can graph this. I guess I'll mention that right here. Can graph f1 of x equal 8 minus 4x. And then just look at the two-dimensional graph, which is your xy graph. So that is possible to do it that way if you want it. And then the number line is like the one-dimensional graph. Okay. So now moving on to this one. This one, they don't give you a function like they did on our first example, and they just want to say where is it greater than 0 and less than or equal to. So it's greater than 0 when it's above. So basically you'd say from negative infinity to negative 1, and that's not including negative 1. And then on this side, from 1 to 3. So again, that's for the greater than. So again, not including negative 1, 1, or 3. Now on your less than or equal to 0, that's the one that actually is going to include those points. And so that's why the above part used parentheses and this part used brackets on the same things, negative 1, 1, and 3. But again, you always use infinity with the parentheses, whether it's positive or negative. So you basically can use your thumb and say it's below here and here, like in between, and then from here to the end of it. That's how you get it. So it's very visual on this one. Okay, on this one, they have it graphed for you, and you want where it's less than 0. And so you just ignore this part, and you say, well, everywhere to 0, and then also union from 0 to 3. So that was kind of like our other example we used earlier, where they did divide it up into different parts. Now, thinking about it, the reason why you can't do negative infinity, comma 3 is because we want f of x less than 0, not less than or equal to 0. So if it did want less than or equal to 0, then I see no problem just using one part. But since we want less than, then we have to split it. So that's actually pretty important. On this one, again, we want to graph it. Just to reinforce what we've been doing, it's already factored for you. So if it's x plus 2, that means negative 2. And if it's x minus 3 squared, that's going to be positive 3 and touches, not crosses. So everything is like building up on each other. Like remember, this one had multiplicity 1, and it was odd, and so it crossed. And this part was multiplicity 2, which was even, so it touched. But we basically just want where it's greater than or equal to 0. And so that's actually starting back here everywhere. So basically have bracket negative 2 infinity. So that is like x greater than or equal to negative 2. Okay. Okay, on this one again we have a graph, and we've got our parts. We want where it's greater than or equal to 0, so that's like above. So left of negative 2, so that's basically that, which was your negative infinity, negative 2. So since this one is greater than or equal to, then I use a bracket. And it's also above over here, so you're going to say right of 3. And we're including that. And then you just put the U for union. That usually just represents or. So it could be here or there. And that's what they are. Okay, so again, very visual for the ones they give you the graph. Now on this one they didn't give you the graph, and so you could just graph it yourself. Now don't try making this a relation. I think one year students got too dependent on making it a relation, but if we just use this as function 1, we could say x minus 9 squared, whoops, squared, and then x plus 3. If we just graph that, we can see our points and use your properties from your equation. Like if it's x minus 9 squared, that's going to be why they have positive 9. That's that where it touches. And x plus 3 is where it's negative 3. So the numbers should correspond. Just remember, flip your signs. And now if we want less than 0, that's going to be below the x-axis. And so there's nothing special happening on the right. It's just over here on the left when it's less than negative 3. So then your answer is a negative infinity, negative 3. or you could say x less than -3. But we wanted an interval notation, so that. Okay, on this one we probably ought to follow our algebraic steps, because if we have x cubed minus 5x squared, you want to factor out your GCF, which would be x squared. I'm just going to put equals 0, and then we'll work it from there. So x squared equals 0, x minus 5 equals 0. So 0 and 5 are going to be your points. Now, if we want below, then we just do our x cubed minus 5x squared. Don't bother graphing the less than 0, just use your mind. And so there's 0, there's 5. Again, if you don't know that's 5, go to your analyze 0 of the graph and get it this way. And if we want less, then it happens on this end. It can't actually be 0 because it's less than. It's less than, not less than or equal to. And so that's why we have this little breakup of this 0. And then from 0 to 5, basically. So all throughout here, it's negative. If you wanted to do zoom fit menu 4A, you could see it completely below until we get to 5. Okay, on this one, in the same way, we would factor out the x. We have x squared minus 4. So then we say x equals 0, x squared minus 4 equals 0, which you probably know would end up being plus and minus 2. So those are our critical points, so to speak, and then we have to just decide where are we, like, are we less than or equal to, greater than or equal to? Are we less than or equal to, greater than or equal to? So in this case, we want this one. So then we can graph it. Excuse me. So x to the third power minus 4x. Looks like that. And we want below. So to the left of -2, and between 0 and 2. So I'm just doing a 0 arrow 2, and so that's the bracket 0, 2, like that. And the left would be -infinity, -2, bracket. Now again, just to say the same thing again, since it's less than or equal to, we use brackets. Since less than or equal to, use brackets, not parentheses. Okay? Now on this one, you're given this already factored. And so if you just flip your signs, you can see 3, 4, and 6 are your x-intercepts. And we want less than or equal to 0. So that means below and equal to 0. Like below the x-axis. So if we do this, with parentheses x minus 3, x minus 4, and x minus 6, then you can see that it's going up between 3 and 4, and it's going up to the right of 6. Now we want below, and so that's to the left of 3, between 4 and 6. So those are the 2 spots. Now I know I told y'all don't use the relation mode, but just here's what that looks like again. If you hit delete and go to relation, it changes it to this. I don't really recommend this, but let's just still see what it looks like. X minus, whoops, let's close this right. X minus 6. Okay, so that's just the left side. Now if you want less than or equal to 0, then you go control equal less than or equal to 0. See, I don't like that at all. That's why I don't prefer this method. That looks yucky. But I guess you can interpret it negative infinity to 3, and then from 4 to 6. Remember, a disadvantage of relation mode is you can't go to your table. Whoa, that was about to be delete all. I was trying to analyze it and go to the 0. It's asking which graph. See, it's harder to deal with if you do it with relation. I guess you can count 1, 2, 3, and then there's 4, 5, and 6. But sometimes you'll get fractions, so I do not recommend using relation. I don't recommend using relations. Okay, on this one, we have x to the third minus 7x squared minus 30x. So the key word in here is it does want you to solve algebraically. So these would be the steps. Any math teacher would want you to take these steps. So change your less than to be equal, factor out your x. So you have x squared minus 7x minus 30. And then you could say, well, x equals 0 is part of it, and x squared minus 7x minus 30 would be the other part. And then anybody would want you to factor it, or you could say graph it. I'd like you to be able to factor it if at all possible, because you know 10 times 3 is 30. And so if we just think we've got to have an x like that, and we've got to have a 10 and a 3, it's a negative 7x, and so we have to put the negative sign with this one and the positive sign like that. So that's how you factor. And so the key points would be where it's 10 and negative 3 and 0. So that's what everybody would want you to do, and then test a point. So you'd say negative 3, 0, 10. So you could test negative 10, you could test negative 2, you could test 5, and you could test 15. If you really wanted to go through all that, you can. I honestly don't see the point. I would just graph it. Some people are visual, some people are more analytical. I'm kind of like both, but in this case, I'd rather just graph it. It's easier to me. Everybody has their own different strengths and weaknesses, so do whatever's best for you. Okay, there's our parts, and so far I just see 2 of them, which is why you might want to zoom out. Okay, now I can see 3 parts. So I'd say zoom out to see all 3. And then we can do our analyze here and here, and that's -3, 0. This one should be obvious. It's 0, 0. Menu, analyze, and then from here to here, that's 10, 0. So we could like just do it like this. Say we want less than, so it's below. Less than means below. So it's left of -3. I'm just going to put a little minus sign. Left of -3. And then it's also below between 0 and 10. And we need to do a little thing like that. And that's a minus also. So between BTWN is my abbreviation, 0 and 10. Whoops, I need to move this over just a little. So I put my little minus sign here, and that's going to be with the parentheses also. And then it's negative there also. So I mean below when I put the little minus sign. And this middle part was above. So if you want to test points, you can, or you can just graph it. So with that said, left of -3 means this, which is negative infinity, -3. And between 0 and 10 means 0, 10. With parentheses. Again, parentheses since it's less than. Use parentheses since less than. Not brackets. I know I keep saying the same thing, but I really can see that being the issue for a lot of people. If you get something wrong, don't get frustrated, or try not to, and just learn from it. Okay, on this one, don't be tempted to divide. On this one, you want to say x to the 4th minus 121x squared equals 0. Factor out your x squared, and then x squared is 0, so x is 0, and x squared is 121. So you can do your square root of 121, or maybe y'all know it's 11. If you were to graph it, I would graph function 1 equal x to the 4th minus 121x squared. Don't use relation. So here we go. X up arrow 4 minus 121x squared. Okay, so the 11s are not going to show up, so we've got to like zoom out a little bit. And so now you see them. Zoom out. And we want where it's above, we want greater than 0, so that's above. And again, we need to use parentheses, not brackets. So at this spot and this spot, so we got to analyze to 0 the graph, and there's your negative 11. Menu 6.1, this side is 11. And then this one is where it's 0, 0, I think. Yeah. But see, it's never above regarding 0. So that's why your answer, you don't even use 0. You just say to the left, like shading over here and shading over here, not shading in the middle. Okay? So that's what your answer looks like. So now on this one, we have x to the 4th greater than 256. You're probably going to have some big numbers on here, on yours, because you want to be able to do the square root twice for these. That's what I think. So we have x to the 4th minus 256 equals 0, or if you want greater than for above. You'd say this is x squared minus the square root of 256 is 16. So x squared minus 16 and x squared plus 16. And that's also a difference of 2 squares, so you can say x minus 4, x plus 4, and leave this end alone. So negative 4 and 4 are what we're interested in. Again, if we just go to the graph, we go with x to the 4th minus 256, and there's your negative 4 and 4. We want above, so left of negative 4 and right of 4. Left of negative 4 and right of 4. Alright, so now on this one, again, it's already factored, so that's why these are so easy. This is just 2, 3, and 4, and you want to see where it's below and use parentheses. X minus 2, x minus 3, x minus 4. Okay, so left of 2, and then in between 3 and 4. I mean, that's how you interpret it. Left of 2, and between 3 and 4. Okay. Now for this one, if we have 3x minus 9 greater than or equal to negative 2x squared, my first step would be add 2x squared to both sides. And now I'm just going to say equal to 0. Now, I'm not going to try factoring that. I'm not going to pretend that, that's an easy thing. I mean, yeah, we could get it by guess and check and so forth, but I would just recommend graphing it. So this is going to be 2x squared plus 3x minus 9. So we do analyze and then 0 the graph. And on this one we get negative 3, 0. Menu analyze 0. This one gives us 1.5, and so you could go to 1.5 menu number fraction, and that's 3 halves. Now notice what I did. I know I kind of pushed my buttons pretty fast, but I was on the graph in a document, right? And so there's my decimal. And so if I hit on, and then I go over to calculate, then I can do whatever I need to. And then I can press on and go to 4, which is current. So that's how I like to go back and forth sometimes. You do whatever you want, but to me, that helps. And so now we want greater than or equal to 0, so that's going to be left of -3, including it. Left of -3, including it. So that's why we use the brackets. And then on this end, we want right of 1.5. Or you could say right of 3/2. And so again, use brackets because it's including. I don't really need to say the same thing again. It's right there. Including that number. Okay. Moving on to this one. Factor out an x. Because x is in both of them. So x is 0, x squared minus 16 is 0, which means x squared is 16. You add 16 to both sides, and then do your square root, which is plus or minus 4. And again, on this one, you want below and on the x-axis. So you go to x to the third power, whoops, x to the third power minus 16x. So those spots, so left of -4 and then between 0 and 4. So that's where it's below. Between 0 and 4. Oops, that's a -4. Okay, so like that. Now 16 is your last one. They want you to do something similar to what we did before, like on a different section, like maybe 4.3 or 4.4. So first, if you see something like that, it'd be graph it. Two x up arrow 4 plus 7x up arrow 3 minus 87x squared. By the way, make sure y'all don't leave out your x's. Minus 395x and then minus 175. Okay, so there it is. Now if we use what we've been learning, this one's touches with multiplicity 2. And then there's one that's crosses and another that's crosses. So let's try to figure out that. So if we go to analyze, 0 the graph, between here and here, that's -5. We can just round that to -5 because it's -4 point and a ton of 9s. So this is at x equal -5, which means x plus 5 squared. By the way, if we're building our factored form of it, we have to put the 2 in front, right? And then this is about crosses. So menu 6, 1, from here to here. This one is negative 0.5 comma 0. So that part's multiplicity 1. X equal negative 0.5, or you could say x equal negative 1/2. Now when we factor that, we would say 2x plus 1. Now that's the part where you may not see that right off the bat, but the main idea is your denominator becomes your coefficient. So let's work in steps on that. We could say in steps it would be x plus 1/2, and so then make that 2x plus 1 like that. Because in factored form they don't like using fractions. Don't use fractions in factored form. And then going back to this other one, it says, well, we're saying crosses, which is multiplicity 1 again. Menu 6, 1, from here to here. Okay, that one's just at 7, 0. So that's x equals 7, which means x minus 7. Now by doing that, all that work, we see x is negative 5 goes here, x is negative 1/2 goes there, and 7. Now, in the factored form, it looks like we're at one step where I need to make sure y'all are doing the right thing. It looks like you should not use this 2 because we have a 2x there. Okay, so this is going to be my one little, I guess, caveat or trick. If you have a fraction, don't put the leading coefficient. So we just want that part. So the x plus 5 squared, oops, let me move this down a little bit. The x plus 5 squared, the 2x plus 1, and the x minus 7. See, if you think about it, multiplying, you would have like an x squared part here, a 2x here, and an x here. So that really is like 2x to the 4th, which is what they want. So because of that, on this problem, you cannot put this leading 2. Don't put 2. Alright. And then it just wants you to graph it, which would look like this. Now their y values are huge. They have y minimum is negative 2400 and y max is positive 2400. That's crazy. Okay, so let's do that. Window settings. The y part's negative 2400 to positive. Okay, so they do want that graph, which looks like that. And then they say the solution less than 0. So that meant below, and so that's basically this area. So from negative 1/2 to 7. You can see that a little bit better on the calculator. From the negative 1/2 to the 7. Not from 0, but it's where your intercept was. Okay, hope that helps. Have a good one.